Okay, hello, this is Dr. James, and today I'm going to talk about this mixer here that I just got. If you're into ham radio or RF or other things, what was it, the X-11 RMS, what is it? RMS X-11, I believe, mixer. And mixers are great. They're a non-linear device. They take two signals, an RF and an LO input, and they create a beat frequency from a nonlinear element, and they put out the difference frequency. So you can up convert or down convert frequencies, so you can extend the range of some of your devices if they're only limited to certain ranges. You can listen to higher frequencies than what your equipment would normally allow you to operate, or transmit at higher frequencies. Great for mad science experiments. Probably be using it for some interesting experiments in the future. Anyway, very cheap mixer. I forget how much you paid for it. It'll be in the link in the video description below. And always remember, helps me out if you order through my links, because I just reinvest everything I get back into the channel pretty much. And let's do some testing of this device, see how it operates. Very cool, huh? Okay, so it looks like it has finally arrived, and let's just see what this is, because I don't know. I forgot what this was. Let's see what we got here. Oh, wow. It's my mixer. Oh, this is so cool. Oh, yes. Does this open up, or do I gotta cut it? Okay, I guess I gotta cut this with the razor blade. So here's a way to extend your RF capabilities up to higher frequencies. It's going to be so cool. I believe this goes up to, what, 2 gigahertz or 1.9 gigahertz? Let's take a look here. Oh, this is way cool. Look at that. Oh, yes. We'll have to test this guy out. Looks like we got some strip line transmission lines to SMA connectors. This is cheap too. I forget, like $20 or something. Okay. Well, we'll be able to test it with some of our sources. Very cool. Okay, let's get going. Okay, let's take a look at this under the magnifying glass. And it looks like this is a mini circuits, well, let's see. It's a RMS-11X. Okay, strip lines going into it. And let's take a look at the spec sheet here. So here is our spec sheet, mini circuits device. And we'll have to make sure we get our power levels right, because too high of a power, you can burn it out. Too low of a power, you're not going to get any signal out of it, or very much signal. It won't be very efficient. The internal circuits. It looks like the LO and the RF do frequencies from almost 0 to 1.9 gigahertz. And it looks like the output frequency can be anywhere from almost 0 to 1 gigahertz. So it has a pretty broad bandwidth for basically you could down convert 1 gigahertz from 2 gigahertz to 1 gigahertz. So this might be interesting for extending the range of your spectrum analyzer or other things. With network analyzer, you'd have to up convert, and I believe this is mainly a down converting mixer. But we'll do some testing with this. I gotta make sure the power levels are right and stuff, because I don't want to burn it out, but we'll take a look and see if we can do some cool stuff with high frequency RF mixers. Okay. Okay, so I just got this mixer, and a mixer is an amazing device where you can put 2 RF signals in, and it will create a beat frequency that is the difference of the two. And well, I was going to test with some devices that I got recently, because I don't have a lot of high frequency stuff at home here. And so we have our signal generator, and I have this set to 300 megahertz. And oh, this mixer, by the way, it goes up to 1.9 gigahertz, almost 2 gigahertz. And this spectrum analyzer can also put out a signal. And I have them both tuned to the same frequency. And if we look here, we have a flat line. So what happens if I change the frequency on this? Here, let's take a look here. I'm going to change the frequency on our signal generator to 301 megahertz. Okay, so they're at the exact same frequency. So it's DC. Okay, so 301 megahertz. Oh, come on, this stupid scope. And again, I have this set at plus 7 dBm output. Okay, so we'll try twiddling up and down in the frequency. So that they're both at the same frequency now, 300, 300, and it's flat line. Okay, we changed that one to 301, and it looks like we're getting a beat frequency out of it, and that should be at 1 megahertz, because that's the difference between this one and that one. And so if I go up to higher frequency, there's 2 megahertz difference, 3 megahertz difference, 4 megahertz difference. Okay, so it's kind of getting out of the bandwidth of the scope. Okay, I think it's aliasing at that point. So let's just bring it down to 1 megahertz, and I'm going to bring up the, let's see, speed of this guy, so we can see the sine wave, hopefully. Okay, there we go, let's put it with the frequency again. Okay, so that's 302. I think that's getting kind of out of the range of this little scope. 301. Actually, let me see. I can change it by like kilohertz. What happened here? Oh, the power went out. Okay, it goes out when you change that, I guess. Okay, so now I have it on a kilohertz setting instead of a megahertz. So I'm going to change it to less than a. Let me put it at a bigger division than that. Do 10 kilohertz. We'll do 100 kilohertz. How about that? Turn the power back on. Okay, so you can see the frequency is definitely changing. So it looks like our mixer's working. Let's go up to a higher frequency. How about that? This is only 300 megahertz. And so this, you can use this to mix high frequencies down. So, for instance, if I wanted to extend the range of my spectrum analyzer here, which I'm using as a signal generator right now, I could use a mixer or maybe a LNA, and I could go up to maybe 2 gigahertz, because this is a pretty cool spectrum analyzer, but it only has a frequency limit of a little bit less than a gigahertz, like 960 megahertz. And so we could extend this up into the gigahertz range by using a mixer, maybe. I can do a lot of other cool things with mixers. Okay, so this is at 300.29 megahertz. This is at 300 megahertz. Let me just, okay, let's take a look at the setup here. I'm going to bring both of these up to, I think this one should go up to about 900 megahertz. Or 960. Let's go up all the way, 960 megahertz. Our stupid scope turned off again. And we will change this one to what? 961 megahertz. Okay. And okay, there. Look at that. Okay, so this is at 961 megahertz, and this is 900 megahertz, and the signal's actually kind of a lot lower now. The mixer must not be as efficient at close to a gigahertz. Let me change this down a little bit closer. Okay, and you can see we're still getting the beat frequency there. Let me boost the signal here because this is getting kind of small. Okay, so there's our beat frequency, and again we're running at 960 and 960.4 megahertz, and I'll twiddle around with the frequency in 100K increments like so. And again, okay, we're definitely changing the beat frequency here. So what you can do is you can use one mixer and set it at a known frequency, and then you could have an unknown signal coming in, and it will bring it down into a range that a lower bandwidth instrument can utilize. Okay, and then you can actually measure, for instance, some super high frequency that you couldn't normally measure with a lower or cheaper instrument, lower bandwidth instrument. Very cool, huh? So it looks like our mixer is working. I'm not going to be able to test it much higher than that. I was hoping to use my spectrum analyzer as a signal source, which could go up to 3 gigahertz, and this one could go up to 4 gigahertz, and test the mixer up to, you know what I could do though? I think I can boost the power level on this. I'm not sure what this mixer wants to see, but if I put too much power into it, it might ruin it. I can't change the power level on that guy, but this guy can go up to plus 13 dBm, so it claims. And okay, I'm not seeing too much of a difference on the output of our signal here. So anyway, here's our mixer. You can put one RF signal in here up to 1.9 gigahertz, and another RF signal in this side up to 1.9 gigahertz, and it will produce a beat frequency output here. No power. It's powered by actually the RF signal coming in, and I guess this is an off-the-shelf chip. Very cool, huh? And our stupid scope turned off again. So anyway, back. That guy's on, that guy's on, and we will skip this again. Okay, so there's our signal back, and again we can twiddle. So what happens when you go on the other side, below the frequency of your local oscillator? It gives you a beat frequency that's the same frequency difference, but on the other side. So you start going farther away, and the frequency starts getting higher. So there's an ambiguity with when you use a mixer. There's two peaks that come through, one on the upper side of the carrier and one on the lower side. So sometimes you have to move your local oscillator around to figure out what exactly the signal is. If there's a, there could be above or below, so you don't know. So, but if you have a tunable oscillator that you're measuring it against, you can change that around. See how you can tune it almost exactly to the same frequency. It's not exactly the same, but you're getting almost a DC signal there, so you can tell that is the frequency now. And like I said, I wanted to use the spectrum analyzer to, we'll see. I'll see if I can find a higher frequency source or something to test this with, because that would be interesting to see how well this guy performs at the higher frequencies. We're only just a little bit less than a gigahertz, which is the limit of this guy, and I can't go too big of a difference because this guy doesn't have that much bandwidth. Anyway, very interesting, huh? Okay, so we'll have to do some more testing with this. Should be pretty cool. Let's see what happens here. There we go. RF Mixer. It was cheap too. It was like, what, $20 or something? I forget. I'll post a link for it if anyone's interested in doing some RF Mixer stuff. Okay. Okay, so here we go. I have a setup to test our RF Mixer here, and done a few videos on. Have a couple other signal generators here. This is a pretty cool one. This one goes up to 6 gigahertz. Let's see, where was the on-off switch on that guy? It's over here. Okay, so this has got an on-off switch over here, And so this is our mixer specs, and I was a little bit worried about putting too much power into it, but it looks like it can handle up to 200 milliwatts. And if I remember correctly, this guy put out like maybe 7 milliwatts or something like that, 6 milliwatts, and this guy was less than that. So I don't think we have a issue with damaging our mixer per se. Okay, here's our spectrum analyzer. I did videos on all these things. I'm putting it into the high input, so I have to change the mode because I believe that standard mode is a low input. Yeah, switch to high in. Oops. High in. Okay, so there's high input. Okay. So I'm running RF, this one, the 6 gigahertz signal generator into RF input, and then I'm running the other signal generator. This one goes up to 4 gigahertz, I believe, a little bit over 4.4 maybe, and to the LO local oscillator, and then I'm running the output into our Tiny SA spectrum analyzer. And looks like I'm seeing some hash right now. Let me just turn these things off. And I don't think there's a power on this one. I think I just have to unplug it. Let me just unplug everything and see if I'm still getting noise. Okay, so these things are generating some kind of noise because that noise level went down when I unplugged it. Let me plug this back in. Okay, so I got these guys both up and running, and so our mixer is good up to almost 2 gigahertz. Let me just set this first one. We're going to test it around 1 gigahertz, and that is 1,000 megahertz, right? Okay, and we have to hit, it's been a little while, I think it's okay, and then okay, so when those arrows are on, that means it's producing RF power, and so we're seeing something on the mixer. And let me change the frequency on this guy here. We're going to change this to 1.1 gigahertz, so it'll be 100 megahertz offset. So we should be able to see that down here. Oh, wait, this is 240 megahertz off, lower band. Okay, so I'm going to have to go up to like maybe 1.5 gigahertz. That's right, this one you gotta go back. You gotta erase everything. 1500 megahertz. Okay, and then we have to go point. We're just going to do a single frequency output. Okay, look at that. Wow. Okay, so this is too much power for the spectrum analyzer, so I'm going to stop this for a second. It's not happy with that. Now, if I remember correctly, there is internal attenuators on this guy. So we'll click on level. You know what I should do? I should get my pen out. They have a neat little pen that goes with these things. Okay, here's our little pen that came with the Tiny SA. So we want to hit attenuate. And I'll turn on the attenuator. Okay, so that's attenuated the signal. And then, I wonder if this pen works on this guy. Point? Oh, it sure does. Okay, there we go. Look at that. Okay, so there is our frequency. And I believe this guy up here has a plus plus and a minus minus. And it's set on the kilohertz range, so that will scroll up or down kilohertz. But kilohertz is kind of small. Let me see. How do we change that? I want to bring it up to okay, 10K. Okay, so we hit this guy down here. 1 megahertz. Okay, so the best we can do is 1 megahertz. And then, okay, there. We have the output power on. Oh, the frequency set to 0. I can't have a 0 frequency. Okay, so I'll redo this. It was 1,000, and that's really a big M there. Don't let that fool you. That's megahertz, not millihertz. Okay, so there is our signal. And remember, we have the plus plus and the minus minus to scroll up and down in frequencies. Okay, that's really... Oh, that's right. We want to change this to... It defaulted back to kilohertz. Just take this back down to 0 kilohertz. Okay. There, we got it on megahertz, and we'll put the output power back on. See, I turn it off. I turn the output power off. Right. The signal goes away, and then when I hit OK, no, keeps on resetting the frequency. Okay, 1,000 megahertz and 1 megahertz offset, and then OK. We're gonna hit OK. Okay, there's our signal. And when I scroll up and down, the plus plus and the minus minus, see I'm changing the frequencies up there. I should be shifting this frequency around. Okay. Okay, so actually the main peak is shifting down because, see, we're going higher in frequency here, and we're getting closer to 1.5 gigahertz. And so this is measuring the delta. Remember, mixers measure the delta between the two frequencies. So these are other harmonics, but as I go higher up in frequency, right, the peak is shifting lower, the main peak rate. Oh, where'd it go? Oh, the mixer reset the 0. Let's turn this guy off. Maybe he can't go that low. Okay. 1,0,0,0,0,0 megahertz, and put it back on the megahertz setting, and put the RF power output on. Okay, so let's shift this down in frequency. Let's just start shifting down, and as I do that, the peak should shift up, which it is. Look at that. Very cool, huh? Keep on shifting the frequency down, and the peak keeps on shifting up. So you can use this mixer here to extend the range of your RF devices. So you can, especially if they're CW type devices, somewhat narrow band. And look at that. Very cool, huh? It does have some other hash in there. Let's see, that peak has moved way up here. So 1.5 gigahertz. And let's see. Again, I'm not sure what the LO output frequency range is, or IF. I guess it's up to a gigahertz. So we should be able to be covered on this spectrum analyzer. And so the input can be from 5 megahertz to almost 1.9 gigahertz, and the output goes from 5 megahertz to 1 gigahertz. And since our tiny spectrum analyzer only goes up to 960 megahertz right down here, we should be good to go. Okay, so I'll keep on decreasing the frequency on this guy, and you can see the peak is shifting up, 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 up. Okay, so it looks like our mixer is working pretty good. Now remember, this is a log scale here, so even though there's hash here, this is I believe it's 10 dB per division, right? Yeah, 10 dB per division right there. So that's every one of those scales is a factor of 10. So this is 10 above this highest other noise peak down here, and it's 15 or so above that. And so, very cool, huh? There's our RF mixer right there, and got our signal, all of our signal generators up and running, and it looks like we are able to you know what we should do, let me bring this up closer to the limit. I'm going to set this frequency here up to 1.8, let's say. Well, we'll put it to 1.9. How about that? We'll stop the frequency there. I'm going to turn the RF power off here, so we have no output there. And let me just change the frequency to 1.9, which is, again, the limit of our mixer. So we should be able to see some power there. 1900. Okay, enter, and I'll turn the power back on to that one. Point. Okay, I guess the power is on that one. Okay, got the power on that one. And I'm going to set this one, since we need an offset of 200 megahertz to even see this, I'm going to just do this at 1.5 gigahertz. 1500000. And this, again, I'm going to change this to a megahertz setting and put the output on. Yeah, let me turn it back off for a second. So there's output off on that guy. So no mixer, output on. Oh, come on. I gotta retype it in. Okay. Output on. Okay. There's off, and there's on. Okay, so I have our two signal generators going, and there is our peak right there. And this is at 1.9, so this is at the limit of the mixer. And of course, we set them both toward the limit. I'll start going up in frequency. Right, we'll start heading toward the limit, and as the frequencies approach each other, remember the IF frequency is going to go to 0 when they're equal to each other. The beat frequency between this oscillator and that oscillator goes to 0 because it's measuring the delta of the frequencies. Okay, so this is 1.9 gigahertz, and this is 1.55 gigahertz. Okay, I'll keep on going up. And as I do that, we are approaching, well, of course, this has a 240 megahertz cutoff, and so we're approaching that. And again, this has a lower scale, so if you want to zoom in on the lower scale, you can do that too, but I just wanted to be able to have a bigger scanning range up here. And so, see, there we go, we're approaching the 240 megahertz difference, and our peak signal is right there, almost at the bottom edge of the scope here. Okay. And let's see, let's set this back to 1.5, I guess. There. 1.5. 0.00000. Okay. And there we go. How cool, huh? There's our RF mixer with our signal generators. Okay. And our spectrum analyzer and everything all together. Very cool, huh? Anyway, this might be good if you need to do some high frequency stuff. You want to bring down the frequencies so you can look at them, or transmit at higher frequencies, step up your frequency. You can do that with this cheap little mixer. I'll have a link in the description. Always helps this channel out if you purchase through those links, because I'm an Amazon associate, and you know, I just the more money that I get into this channel, the more fun things I can do, the more videos I can make, because I just basically reinvest all this money to create more fun stuff here. Anyway, thanks for watching. This is Dr. Janes.